Hi, and welcome to our YouTube channel. I'm Ashley.
I'm Eugene. I'm Jason.
And I'm Anuj.
And we are
The Physics Paragons.
We are a select few students of Lamont High School interning with Argonne National Laboratory under Dr. Steve Kuhlman for research relevant to the Dark Energy Survey. In order to better understand the scientific probes used within the Dark Energy Survey that study the behaviors of the expanding universe, like baryonic acoustic oscillations, it is helpful to know and understand the basics of particle physics, like what a baryon is, for example, and that's what our channel will mainly focus on.
In this video, we will be covering the standard model of particle physics, something so important to modern-day physics that it is regarded as a theory of almost everything. So, you're probably questioning at this point what the standard model of particle physics is.
Before we start talking about the standard model, we should all be on the same page on what particle physics is. In a nutshell, particle physics is the branch of physics that focuses on the nature of particles that compose and facilitate matter, radiation, and the forces that bind our universe together. Instead of studying subatomic particles like protons and neutrons, particle physics looks at what makes up protons and neutrons. The things that make up these subatomic particles are known as fundamental particles that ultimately can't be broken down any further. There are currently 3 known classifications for these particles: quarks, leptons, and bosons, and the standard model is currently the dominant theory in explaining the existence and the interactions of these fundamental particles.
Some of the particles listed by the standard model behave similarly to atoms. For example, atoms are known to group together to make ionic and molecular compounds. Quarks are known to group together to make protons and neutrons. Therefore, quarks are known to be among the smallest building blocks of all matter. Leptons are also considered alongside quarks as the smallest building blocks of all matter, as the electron of an atom is classified as a lepton. Quarks and leptons therefore make up everything that is made up of matter, everything, from the electronic device you are using to see this video to your own beating heart. This is how the scientific community currently sees as the most basic way of looking at matter, and the fact that the standard model lists these building block particles in this sense is one of the reasons why it is so important to modern day physics. And just an FYI, because this is only an intro video to the standard model, there will be separate videos linked to this one that are dedicated in explaining all the terms and constituent parts of particle physics that are not covered in this video, such as hadrons and baryons.
Now is where the very important stuff comes into play. Bosons are a third classification of fundamental particles in the standard model, and unlike quarks and leptons, they do not make up matter. However, bosons are extremely important in particle physics because they are known to be force carriers which facilitate 3 out of the 4 fundamental forces in the universe: electromagnetic, strong nuclear, and weak nuclear forces. Sorry, gravitational force, you're just a different topic for a different video. Generally, electromagnetic force is among the most recognized forces when studying particle physics. And this is not surprising considering that many everyday devices like cell phones and laptops use electromagnetic force to operate. The photon is one of the bosons responsible for this electromagnetic force. And if you're familiar with the recent discovery of the Higgs boson, it is responsible for facilitating mass for certain particles in the universe, which we will discuss more about in future videos along with other topics that we haven't dived into.
If you're wondering why we haven't mentioned about bosons being responsible for gravitational force, well, the fact is that the standard model, as of right now, can't satisfactorily explain it in the context of particle physics. What is believed to be a gravity force carrier, the graviton, may someday be discovered and recognized as a fundamental particle of its own. The silver lining in this situation is that with our current model, the effects of gravity are extremely minuscule in most particle interactions compared to the other 3 fundamental forces. And on this note, we'll wrap up our intro video of the standard model of particle physics.
Hope you liked everything that we said so far. Now you know more about why this topic is so significant in the study of modern physics. Check out our other videos that are relevant to the standard model by clicking the links that are somewhere on my left or my right. Thank you for watching, and tune in next time with the Physics Paragons.